Hello and welcome everyone. Thanks for tuning in. Today we're going to talk about how to put your Cassandra Python driver on steroids with Apache Arrow. First, a little bit about me. My name is Arthur Andres. I'm a software engineer at Tradewell Technologies. The topic of the day is a typical Python use case where you're receiving a batch of raw binary records on the I/O, and you want to pass this data to an analytics workload in Python. And quickly you realize that Python is a good tool for analytics, but it's got great libraries for that, like pandas for data wrangling or scikit-learn for machine learning, which are highly optimized. But when it comes to parsing binary data, it's notoriously bad. It's very slow, and it uses a lot of memory. So one solution is we can offload that part of the job, the boring part, the raw data parsing part, to a faster language like C++, and return the data in a shape that's usable by Python efficiently. Historically, the way to do that has been NumPy. But NumPy has got a few shortcomings, and mainly it typically only works with two-dimensional arrays of doubles. But recently, Apache Arrow came along and addressed those shortcomings. And in particular, it supports a rich API for sharing in-memory structured columnar data across languages with zero copy. So in this talk, we look in particular at Cassandra. Cassandra is a NoSQL database that can deal with huge amount of data. And more specifically, we look at the Python driver, and we'll see how we can optimize it with Apache Arrow and C++. So let's get started and have a look at the Python Cassandra driver and see how it works with a simple example. So here I'll do a very simple query against a very simple table using very simple type like date, integers, timestamp, and doubles. So I'll connect to the database, I'll execute my query, and you can see that I received like 36,000 records. Each record represents a row, and each row is using a tuple as the data class. Tuples are very common in Python, and they're very simple, but they're also very bad for analytics. And I'll show you why briefly. So the first thing you notice is that if I want to calculate a simple metric, I have to write a lot of imperative code for that, which can quickly become messy and buggy, and it's not very Pythonic, so that's not great. The next thing I notice is that I had to write a for loop, and for loops in Python are very slow. So it took 2 milliseconds to process 36,000 records, and we can do much better than that. On top of that, you can see that it uses a lot of memory. So in this example, 36,000 records are taking 13 meg. But if I pay close attention to the data, I can see that I would expect each row to only use 24 bytes. And in total, it should take less than a meg. So we've got a factor of 15 override in terms of memory, which if you're dealing with a large amount of data may blow up your servers. And lastly, I've noticed that the types that are being used by the Cassandra driver are proprietary type with a non-conforming API, which means I would have to convert this data before I can make use of it, which is rather frustrating. So all in all, this is not very good, and we would like to improve it. So let's try to find a better solution. And this solution, I call it Casaro. And with the existing driver, what happens is that we receive raw data. We've got the Python driver that uses Python code, which is slow to convert the data to tuples, which are unusable. With the optimized version, the Casaro version, we're going to use C++ code to convert the raw data to an arrow table, and it's going to be much faster to convert the data and put the data in the shape that is much more convenient. So you're probably familiar with this chart if you ever used Arrow. On the left-hand side, you've got the Cassandra row-based representation of the data, where the data is represented row by row. And then on the right-hand side, you've got the Arrow representation, where the data is represented column per column. And essentially, what we're trying to do in this exercise is convert the row-based representation of the data into the columnar representation. And this is a two-step process. The first step is to convert the Cassandra metadata to an arrow schema. So whenever I send a query to Cassandra, the first thing I get back is some metadata about the results. And in this metadata, I get the name and the type of each column. This is using a proprietary type representation that's specific to Cassandra. But as you can see in this table, the Cassandra types fit nicely in the arrow type system. And I can convert most of the native types from Cassandra to arrow. And the same thing can be done with complex types like list, map, and user-defined types. They also fit nicely with the arrow type system. So that's the first step done. We've got the schema of the data. The second step is to convert the actual data. And for this, we're going to, again, rely on the great APIs that are provided by Apache Arrow. And the key abstraction we're going to use here is the array builder. So the array builder is an interface that allows you to add an element to a buffer one by one to eventually create an immutable array. So as we iterate through each row that we receive from the driver, we will add each field to the relevant array builder. Once we're done consuming all the data, we'll convert the array builders to arrays and convert those arrays, put them together in a record batch, put those record batch into a table, and we'll get the results. So let's see what it looks like in real life. So here I'm going to execute a query, the exact same query actually, with the optimized version of the driver. And all I've done is wrap the existing Cassandra connection into a Casaro connection, which essentially just changes the way the data is handled and parsed. All the rest remain the same, so we don't need to reinvent the wheel. We're just changing the part that was inefficient. And after executing my query, you can see that the result come out as an arrow table. We solved all the problem we had seen before. I've got a great API for calculating metrics and doing analytics. It's much faster. So what used to take 2 milliseconds now takes 16 microseconds, which is 100 times faster and more. And lastly, in terms of memory, it's using exactly the amount of memory it should be using with zero overhead. So that is solving all our problem. But if you're not convinced yet, let's do a quick benchmark. So for this benchmark, the first thing I'm going to do is execute a query with the default driver and with the optimized version of the driver. And as you can see, the optimized version is faster. It's shaving off 60 milliseconds, like 30 or 40% faster. But typically, when I convert like Python code to C++, I expect it to be 10 times faster, and it's not the case here. The main reason is that most of the time when we execute a query, it's being spent on the server fetching the data, and also on the network layer sending us the data. So to have a fair comparison of the driver, really what we want to compare is the time it spent converting the data, which I've done here by quite simply like taking some raw data coming from the server, putting it into memory, so I bypass the I/O layer, and then I convert how much time it takes for the default version of the driver to parse the data, and my optimized version of the driver. And as you can see here, it's 10 times faster. So here we go. That's all our problem solved. Everything is much faster and nicer. So in conclusion, if you're curious about this, I would recommend you check the code. It's available on GitHub. If you're a Cassandra user, why not give it a try and install the library? And lastly, if you're facing similar problems, like, for example, you have to parse binary data. It can be in any format. It can be JSON. It could be protobuf. Why not try to apply a similar approach and use Apache Arrow and C++ to speed up this type of workload? Thank you very much.